Now, I want to discuss some likely examination questions for 2026 examination UTME question. They say this what? The density of a small metal rod can best be determined by using dash. A. Vernier caliper. B. A vernier caliper and cylinder of water rather. B. Micrometer, screw gauge and beam balance. C. Vernier caliper and spring balance. D. Mass rifle and lever balance. I think because of the small ball, to measure the radius of a small ball, we use what? A micrometer, screw gauge. And then to measure the mass, because we know that density is mass over volume, we use beam balance. So the best answer to that number one is what? Micrometer, screw gauge and what? Beam balance. Because once you can get the radius, you can now say density is equal to mass over volume. Now let's go. Don't forget that you can get the volume by what? Measuring what? Pi r square each. So pi r square, radius can be gotten by the external or diameter of the rod, then divide by 2 through micrometer, screw gauge. Now let's go. Number 2 says what? What is the unit of impulse? Impulse is equal to what? Mass times velocity, which is what? Kg meter per second. We have what? A. Kg meter per second. B. Kg meter per second square. C. Joules. D. Kg meter per second square. Now this one is kg meter second rather. Then the answer is what? Option A, which is kg meter per second. Kg is for what? Mass. Meter per second is for what? It can also be measured in Newton second. Don't forget. Number 3, we say which of the following is a scalar quantity? A. Momentum. B. Electric field. C. Power. And D. Magnetic field. All field are vector. So electric field is vector, magnetic field is vector, momentum is a what? It's also a vector. The answer to that question is power. Let's go to number 4. Number 4. They said a tennis ball is thrown upward from a point B with a velocity of what? A what? Look at it. From a point P with a velocity of what? Velocity upward from a point P with a velocity of 50 meters per second. Upward with a velocity of what? 50 meters per second. So this is what? 50 meters per second. What they say we should find? Calculate the time it takes to return. It takes the ball to return back to point P. So let's say the level of P. Let's use the P here because they are the same level. So let's take this level as the level of P. So point P return back to point P. So up and return back. Now for us to calculate the what? The time here, we use what? S equal to what? Ut minus, because it's thrown against gravity, half what? Gt squared. They did not give us G, but we can take G as 10. Now, when the body is thrown upward, it's thrown with what? This one, U. So we are going to use what? U as 50. Then S is equal to what? Our S. S is what? H1 minus H0. Initial height is what? H0. Final height is what? H1. So since it's thrown from point P and landed back at point P, that means H1 is equal to H0 and it will equal to what? 0. Since it's thrown from the point P and landed back at point P. So that means that what we are saying is that the displacement is what? 0, which is 0. Now, what again I will give in here? We are giving velocity as what? 50 times time minus half. Minus because it's going against gravity at first. So times 10 times what? T squared. So we'll play with it. This one cancels our 5. So we have 50t minus what? 5t squared. So what is common? Equal to 0. What is common is now what? We are going to have what? 5 is what is common. Yeah, what we mean here is 10t. 5t is common rather. What one would have is what? 5. Then is t, because 50t divided by 5t will give us 10. Then what one would have is what? 5 what? T is equal to 0. Now, what I'm going to do now, remember that you have factorized t out. That's why t is out. 50t divided by 5t. 10. 5t squared divided by 5t. That is t. Sorry for that. T. So now, what will you have? If you open the bracket by 5t times 10 is 50t. 5t times t is 5t squared. So it's correct. So we can now solve and say, let's now see what 5t is equal to 0, which is t equal to 0, or 10 minus t equal to 0. So what do we have as our t? T will now be equal to 10 seconds. So it takes what 10 seconds to go up and come down. You can also calculate the time it takes to go up, which will take 5 seconds. The time to come down is also 5 seconds. You add them together. 5 plus 5 is 10. So our answer will be what? A says what? Let's say what? A tennis ball is thrown vertically upward from the point P with a velocity of 50 meters per second. Calculate the time it takes the ball to return to P. A, 4 seconds. B, 6 seconds. C, 8 seconds. D, 10 seconds. And the answer is 10 seconds. 10 seconds. Let's go to what? The next question. Number what? 5. It says, which of the following statement is correct about friction? Roman figure 1 says what? It is independent of area of in contact. Yes. Roman figure 2, its effect is felt more for smooth surface in contact than rough surface. Wrong. Rough ones. It is what? Felt more in what? The effect is felt more in rough surface than smooth surface. So that one is wrong. Roman figure 3 say it wastes energy. Yes. Because frictional force causes heat, and heat is what will be wasted as energy. We lost as heat, and thereby reducing the efficiency of what? Of the machine. So we go for 1 and 3. 1 and 3 is better. Number 6 says what? A crane lifts a load of 250, weight of 250 Newton through a height of 12 meters in 5 seconds. Calculate power. Want to calculate power for this question. Now to calculate power is equal to force times distance over time taken. To calculate power is what? Power equal to what? Force. Power equal to force times distance over time taken. To calculate question, we use DSS. DSS, you what? Take your data. They say a crane lift a load of weight. What is the weight now? Weight is 250 Newton. Then what about our what? They say through a height of 12 meters. That is height of 12 meters in 5 seconds. Time is 5 seconds. Okay. Calculate the power of the crane. The power of the crane will now be equal to what? The weight times height over what? Time. Don't forget, weight is also the same as what? Mg times what? H over height. Mgh over T. Rather. So we are going to have what? The weight is 250 times what? H is what? 12 divided by what? 5. So 5 here you have 5. That is 50. 50 times 12. What do you have? 600 watt. So we are going to have 600 watt as our answer. Don't forget 600 watt. Option A is say 50 watt. B is say 104 watt. C say 600 watt. D say 800 watt. So the answer to that question is what? Is 50 watt. Don't forget this is 50 because this one is still there. So 50 times 12 is 600 watt. Now they say number 7. It is more convenient to use a lever when the effort is dash. They say it is more convenient to use a lever when the dash A effort closer. Now don't forget, if I have a machine like this, the effort is, let's say here, smaller effort. Then we have a longer distance moved by effort. This is a fulcrum. Then we have heavy load. The load is heavy. Then we have smaller distance by effort. This is a typical machine. So that means that the load is closer to the fulcrum than the what? The distance moved by effort. So you use smaller effort to overcome bigger load, and you use smaller, longer distance of move by effort to overcome to surpass the shorter distance of what? Load. Don't forget that the distance moved by effort must be greater than distance moved by load. Then the load must be higher than this effort for it to be called a machine. So the question now says that it is convenient to use a lever when dash. A, when the load is closer to the fulcrum than the effort, better. The option D is the answer. Option A says effort is closer to the fulcrum than the load. B, load and the effort are at the same distance from the fulcrum. C, effort is more at the fulcrum than at the fulcrum. D, load is closer to the fulcrum than the effort. The next one, number 8, says what? A machine is 75% efficient, has a velocity ratio of 4, and the velocity ratio is 4. If the effort is 10 Newton, or if an effort of 10 Newton is applied, on the machine, calculate the heaviest load it can lift. Calculate that we are looking for load now. So for us to solve for load now, what we are going to do is to use the formula. Efficiency is equal to what? Load over effort divided by velocity ratio. So which of this formula can be written as what? Load over effort times what? Velocity ratio. That is it. So in this question, we are giving velocity ratio as 4. Then we are giving what? Effort as what? E as what? 10. We are looking for load. So load is unknown. Efficiency is what? 75%. So what we are doing is 75 over 100 equals to what? Load is what? Unknown over effort times what? Velocity ratio. We cross multiply. What do you have? Load is equal to what? Times 100 is equal to what? 75 times 4 is 300 times 10. So divide both sides by 10, or by 100 rather. This one will cancel this one. What do you have, class? We're going to have what? This will cancel, this one will eliminate. So our answer will now be what? 30 Newton. So the load will be equal to what? 30 Newton. You can do your calculation well, because 75 times 4 is what? 300. 300 times 10 divided by, you get your answer. The next one is what? Number 9. They said what? The pressure of at the depth. Number 9. They say what? The pressure at what? The pressure at a depth is of 7.2 meter below the surface of a liquid is. So the depth H is what? 7.2. Below the surface of a liquid is what? 2.4 times 10 raised to what? 4 Newton per meter square. So calculate the density of the liquid. A, 3.0 times 10 power minus 3 kilogram per meter cube. B, 3.0 times 10 power minus 2 kilogram per meter cube. C, 3.3 times 10 power 1 kilogram per meter cube. D, 3.3 times 10 power 2 kilogram per meter cube. So what I want to do now is pressure equal to what? Rho GH. That's what formula I want to use. Yes, G is 10. You don't know it now. G is 10 according to the question. They give us G. Okay, no. Okay, they give us G as 10 meter per second square. So what I want to do now is to make density solve for my density is rho. But the pressure over what? Divided by GH. So what do we have now? So if we get pressure at what that, we are going to have 2.4 times 10 to the power 4 divided by what do we have there? 7.2. Right? Okay. Let me say 10 times 7.2. Let's play with it. Now, this one is safety as what? 24 over 72. We can have what? 24 times 10 to the power 4 divided by what? 10 times what? 72. Okay, 2 year, or let's say 12 year, 2 year 12, 2 year, we are going to have 36. Yes, 2 year 12, the 12 year 1, 12 year what? 3. So what else we have there? We have this one will cancel, this one we have 1,000 divided by 3. So our answer for pressure will now be what? 333.333. If you press your calculator very well, which is about what? 3.3 times 10 to the power 2 kilogram per meter cube. So that will now be our answer for pressure. So, or density rather. Density is what we are looking for. Density. So that is the unit of density. Now we want to look at number what? Just in number 9. Let's look at number 10. Number 10. They said what? That which of the following is a factor that influences the rate of flow of water? Which of the following that affect the what? The factors influencing the rate of flow of water through the pipe to house. Through what? A pipe to houses. Now, number 1, they say what? The material of the pipe. Yes. It all depends on the surface material of the pipe. Is it rough? Sorry for that. Is it rough or clean? Is it rough or smooth? It's also it depends on the material of the pipe. Now, it also depends on the diameter of the pipe. Don't forget that flow rate is equal to volume over time, which is also the same thing as what is we write as. We can write it as area times what? Times velocity. So velocity of the fluid. So we can say that flow rate is equal to area times velocity of the fluid. So that is now what? Our answer. Our answer now be Roman figure 1 is the material of the pipe. Roman figure 2, the diameter of the pipe. Roman figure 3, the viscosity of water. So the answer to that question, we have option A, 1 and 2 only. B, 1, 2, 3 and 1, 2 and 3 only. C said what? 1 and 2 and 3 only, sir. D says 2 and 3 only. The answer to that question is B, which is what? 1, 2 and 3 only. Number 11, which is what? A question on density. He said a solid weight 22.5 Newton in air and 15.0 Newton in water and 17.5 Newton in a liquid X. Determine the relative density of X. Now what we're going to do is to find the relative density of X. And in doing that, what we're going to do is to use our formula. Don't forget our formula. The formula to solve that problem will now be what? Relative density is equal to what? Weight in air minus weight in liquid over weight in what? Air minus weight in water. So obtuse in liquid over obtuse in water. That is what? Relative density of what? Of X. So what we have what in air is 22.5 minus what is in water in air liquid 17.5 divided by what? 22.5 again minus 15. So what do we have now? Let's play with it. 24.5 minus 17.5. That should be giving us what? 5.0. 5.0. And do your findings. Then 22.5 minus what? Minus 15 was what? 7.5. So which is safety as 50 over 75. We play with it. 5 here is 10. 5 here is what? 15. Yes. Then what again? 5 here 2. 5 here 3. So we are going to have what? 2 over 3 as the relative density of X, which is what? The same as 0. What? 666 is about me what? 0.7. You can confirm it. Don't forget, relative density does not have a unit. So that is how you solve your answer for that question. Now we go to the next question. Next question. Which question are we now? We are in number 12. Number 12. They said what? A 7.5 kilogram of water. A 7.5 kilogram of water at 50 degrees is mixed with what? Now we are mixing what? 7.5 kilogram of water. A 7.5 kilogram of water. That means the mass of hot water, 7.5 kilogram of water at 50 degrees Celsius. I mean, temperature of the hot water is for 50 degrees Celsius. It's mixed with what? With 5 kilogram of water. 5 kilogram. Don't forget the last question. The answer is what? 0.67, option C. So now what the number next question says what? What 7.5 kilogram of water at 50 degrees Celsius is mixed with what? 5 kilogram of water at 95 degrees Celsius. That means this one is hot. Then how do I know this one is cold? So this is hot, this is cold. So this mass of hot water, 5 kilogram, this mass of cold water. How do I know this what? 95. So then I say calculate this hot. Calculate the temperature of the mixture. So the temperature of mixture is what we are looking for. Temperature of mixture for the two of them. Now the two of them are the same thing. Temperature of mixture. Now what we are going to do now, provided it is not lost to the environment, what we are going to do now is that MC what? C is temperature, specific capacity of water times change the temperature of the cold substance, because heat gain by this is equal to heat lost by this. So in this case now, we're going to have M what of hot water times C of what hot, that means C of water times change the temperature of this hot water. Now, what I want to do now, what the temperature of cold substance? It will now be what? This will be the final temperature of the mixture will be the final temperature. Why would this one be the initial? So I want to have what? 7.5 times what? This one can cancel this one. What is what? Final temperature is what? Tm for the cold substance times 50 is equal to what? What is the mass of your substance, hot substance? 5 times what is the final temperature? Is 95 minus what? Tm. Because this one will be the final temperature, while this one will be the what? Initial temperature. But for the cold substance, the temperature of the mixture will be the final, while the temperature of the cold substance of this one will not be what? The cold, that means initial temperature of the cold substance will not be the what? Initial temperature. So this one will give us what? 7.5. You open the Tm minus 75 times 5. We give us 5 carry 2, 35, 37. 375 is equals to what? Then 95 times what? 95 times 5 times 5 will give us 5 carry 2, that 475 minus 5 Tm. We play with it. Now what I want to do now is collect like terms. Let this one go there, let this one go there. I want to have 7.5 Tm plus what? 5 Tm is equals to what? 475 plus 375. I need an answer to this question. So this one will got 12.5 Tm is equal to what? This one will give me 0 carry 1, 5 carry what? 1, 7, 8, 850. So Tm will now be equal to what? 850 divided by what? 12.5. So that will give us 68 what? Degrees Celsius. So we have option A, we have what? 68 degrees Celsius. Yes, option A, we have 70 degrees Celsius. B, we have what? 68 degrees Celsius. C, we have 65 degrees Celsius. D, we have what? 60 degrees Celsius. So that would, the answer would be B, 68 degrees Celsius. So we are going to end this section like this now. And when we come back, we continue another section of this class. Thank you very much. God bless you.